In section 3.1, you're going to be solving systems by graphing, and you're going to be classifying those systems. So, a system of linear equations occurs when you have two or more equations in the same problem. To start out, we are just going to be looking at a system with just two linear equations. So, when you graph a system of linear equations with just two equations, you're going to get exactly two lines. And multiple things can happen when you graph two lines. In part one of this video, we are just going to be looking at a problem where the result is finding exactly one solution. So this is an example of what an equation like this might look like. You have two lines, they intersect in exactly one point, and that point where it intersects is going to be our solution. So, we know in this case that we're always going to intersect in exactly one point. That will give us one solution. And our classification of this system is going to be consistent and independent. What helps me memorize my classifications? I know when I have a solution to a system, that system is consistent. And I know when I have exactly one solution, that solution's independent. And I try and think about an independent person who likes to do things on their own and maybe does not need help or thinks they don't need help. Alright, exactly one solution is independent, just like a person is independent because they like to work as one on their own. That's how I remember it. If you have a better way, I mean, by all means, if it works for you, use it. Alright, you're just going to have to memorize what consistent and independent is and when to use it. So, let's look at our first problem. Alright, we see our system right here. System of two linear equations, y plus 3x equals 5 and y minus 2x equals negative 5. So, the first step is we're going to want to make sure each of those equations is in slope-intercept form, which is y equals mx plus b. I'm going to go ahead and get green here, and we can see neither of our two equations are in that form, so we're going to have to rewrite both of them. So I've got y plus 3x equals 5. And I want to get it in y equals mx plus b form. So I'm going to subtract over my 3x, so my y is alone. I solve this equation for y. And I get y equals negative 3x plus 5. And now I'm in this form, where I have an m of negative 3 and a b of 5. Do the same thing with the second equation. Y minus 2x equals negative 5. I'm going to add over 2x to each side. Alright, negative 2x and 2x will cancel. And I see y equals 2x minus 5. Also in slope-intercept form. M of 2, b of negative 5. Once you have two equations in slope-intercept form, the next step is to graph them. Normally, you only need 2 points when graphing a line. Technically, that's still true, but I'm going to highly encourage you to use more than 2 points to graph a line when you are trying to solve a system using the graphing method, which we're doing here. Alright, because you need to have very accurate and exact lines. Alright, you don't want them to be off much because we're looking at the intersection point as our solution. Alright, so if you use 3, 4, 5 points when graphing one line, it's gonna save you a lot of trouble in the end. I promise you that. Alright, so let's take a look at that. Let's first graph this one. Alright, so we're going to start by graphing our y-intercept, which is our b, which is 1, 2, 3, 4, 5. So we've got a point right here. Our slope is negative 3, or negative 3 over 1. So it's negative, so I need one negative movement and one positive movement. So I'm going to go down 3, that's my negative movement, right 1, that's my positive movement. From this point, I'm going to go down 3, negative movement, right 1, positive movement. Again, down 3 more, right 1. So I'm going to just use 4 points here. All right, we can see they form a line. So I'm going to draw a straight line which passes through these points. Well, relatively straight. Kind of got a little crooked there, but still good. All right, if you kind of miss a point, you can make it a little bit bigger so it looks like it's passing through each of those points. Now we're going to go ahead and graph the second line, y equals 2x minus 5. So I'm going to plot my y-intercept of negative 5. 1, 2, 3, 4, 5. And I have a slope of 2, which is like 2 over 1, and it's positive. So I need 2 positive movements. So I'm going to go up 2, right 1, both positive movements. From this point, I'm going to go up 2, right 1. It looks like we're sharing this point right here. Then I'm going to go up 2, right 1. So once you find a point that both lines share, guess what? That's going to be your solution. Alright, so draw a line which passes through here. Alright, that intersection point is our solution, and it looks like it's at 2, negative 1. Alright, but before you say, oh, I'm done, I got my solution, you want to make sure that that's actually correct. So, by using multiple points, it was easier for me to find the solution. It's more accurate. So coming down here, you're not going to be pulling your hairs out when you're checking and trying to get the correct answer. Alright, and see if you have the correct answer, I should say. So, when you check, make sure you go back and use the equations from the original system. So we have 2 equations. One's y plus 3x equals 5. And the other one was y minus 2x equals negative 5. And these are both my original equations. So I'm going to plug in the point 2, negative 1. Right? So remember 2, negative 1, the ordered pair is x comma y. So I'm going to plug in 2 for x and negative 1 for y. So negative 1 for y, 3 times 2 equals 5. I'm just going to evaluate the left side. So I've got negative 1 plus 6. And then negative 1 plus 6 is 5. So we see 5 equals 5. And that checked. Coming down here, I'm going to plug in 2 for x, negative 1 for y, just as I did previously. Evaluate just the left side. Negative 2 times 2 is negative 4. And negative 1 minus 4 is negative 5. So both of those check. So you need to make sure you check with both equations, all right, because you may see that you find a solution that works with one equation but not the second. Has to work with both, and we can see we've got the same number on both sides of the equal sign, so we know it does work. So our answer is 2, negative 1, and don't forget to include your classification. A lot of times people will forget to do that. Alright, and remember we said the classification for a system with just one solution is consistent and independent. So I'm going to write that down here as well. Consistent and independent. And now you're done.